Hi, welcome to the topic on techniques of differentiation. Now today's lesson you are expected to have certain basics regarding how to differentiate. Now I will briefly run through the various rules like for chain rule, the product rule, the quotient rule, so on and so forth. Let us begin. Now this is a composite function. What is a composite function? A composite function is a function within a function. This is a very important rule, all right, for for chain rule. It's used to differentiate composite function. Composite function like sine 2x, cos x squared, ln x cubed, all right. Ln is a function, then x cubed is another function, cos is a function, then x squared is another function, so cos x squared is a function within a function. So you differentiate this. Now how to differentiate? Now you differentiate the outside function first with the remaining function, the inside function remains unchanged. So you have f prime g of x. Then you differentiate the inside function, it will be g prime x, and you multiply them together. Now this is for product rule. Product rule is you differentiate one of them, the other one remains unchanged. Next, you differentiate the other one. That means in this case you differentiate your g of x, you get g prime of x, and f of x stay. Now this is a function divided by a function, so we use quotient rule. Quotient, you come from, where does the word quotient come from? The quotient comes when you do a division. So this is something divided by something, so you use quotient rule. So first you square the denominator, so v square. Then you take the denominator, that is vx, v. Then you differentiate the numerator, du dx, minus, this is for quotient rule is minus. Then you take the denominator, numerator remains unchanged, and you differentiate the denominator. Now how to differentiate cos f of x? Now differentiate cos x, you learn in trig differentiation, you get minus sine x. So this is a composite function, so you differentiate your cos first, you get minus sine. You get minus sine. What is inside remains unchanged. So f of x here. Then after that you have to differentiate the inside function, which is f prime of x. Now how about this? It's the same thing. You differentiate sine f of x, you differentiate sine first, you get cos. So you got cos f of x. And then you differentiate fx, you got f prime of x. Same thing goes for tangent f of x. If you apply the chain rule, you will have f prime of x followed by secant square f of x. Now because you differentiate tangent x is secant square x. Now how about this? You differentiate ln x is 1 over x. So if you apply chain rule, you differentiate the ln first, you will have 1 over f of x. And then you differentiate f of x, you have f prime of x. I have briefly run through the various rules with you. Now let's start off with question A. Now, how do we differentiate this function here? Some of you might think that we will use quotient rule because it's something divided by something. Now, let me remind you that we try to avoid quotient and product rule unless if we do otherwise, we find that it is very tedious or we have no choice. In this case, it is easier, all right, if we don't use quotient rule. So how am I going to do it? Now, let f of x be equals to 7x squared. Now, this you can break it up into partial fraction, all right, into two different parts. So 7x squared over root x minus 3x over root x. Then what will this become? This will become 7x to the power of 3 over 2 minus 3x to the power of half. Now then we can differentiate this using the direct differentiation, all right? So we bring the power down. You have 21 over 2. Then you minus 1 at the power, you have half here. Then you bring the half down for this, so you have 3 over 2. And then you minus half, minus 1. So you got x to the power of minus half. Now you simplify this. So you have 21 over 2 root x minus 3 over 2 root x. Now you may leave your answer in this form also, alright? I don't suggest you to simplify just in case you make a mistake. Or unless they say they want the radical form. Radical form is the root form, and they don't want this index form. Otherwise, just leave it. Now question 2, question 1b. So again, f of x be equals to x into x cube of x. Now how to differentiate this? What rule shall we use? Here I should put f prime of x, sorry. So this should be f prime of x, okay? Now, when I differentiate this, all right, this will be equals to f prime of x. Now, I use product rule because something times something. So let's differentiate the x first. You get 1, so you are left with sine x cubed or cube x. Then after that, now this one stay, and then we differentiate sine cube. So differentiate sine cube is 3 sine square x. Then we differentiate sine x. You got cos x. Okay. Now you can see that sine square x is common. So we can factorize them out. So you got sine square x into sine x plus 3 x cos x. Okay. Now let's move on to C. For C, let f of x be equals to e to the power of 2x over 1 minus e to the power of 2x. Now which one should we use? We will use quotient rule because this one we have no choice. We can't break it up. All right, because below is not just a single term. All right, this is 2 terms, whereas here is just a single term. So we can break it up using partial fraction. So you have f prime of x is equals to, now you square the denominator, there's v squared 1 minus e to the power of 2x squared. Then you copy the numerator because it's v 1 minus e to the power of 2x. Then you differentiate the numerator. So you got 2 e to the power of 2x. Then you minus. Now minus, now this part remains unchanged. So you have e to the power of 2x. Now we differentiate the denominator. So you differentiate the denominator. Differentiate 1 is 0. So you have minus. So you e to the power of 2x, you differentiate with e to the power of 2x. Now you differentiate the 2x. So you become 2. Alright, then let's multiply it out and simplify. So you have 2 e to the power of 2x minus 2 e to the power of 4x plus 2 e to the power of 4x over 1 minus e to the power of 2x whole thing squared. And then what do you get over here? Now these two, they are identical, so they cancel each other. So you are left with 2 e to the power of 2x over 1 minus e to the power of 2x whole thing squared. Let's carry on with D. Now, look at this. How are we going to differentiate this? Some of you might think that let's do it by composite function. You differentiate ln x is 1 over x. So this will be 1 over this. Then after that, you need to differentiate this itself, the inside, using quotient rule. Now, not that you cannot do that, but it's going to be very, very complicated. Now, when you see a ln or a log, sometimes we can make use of the properties of log to help us. Now, let us begin. So you have, let y be equals to ln square root 3x plus 1 over 1 minus 2x. Now this is to the power of half. So you know log, you can bring the half down. Alright, so it is equals to half ln into 3x plus 1 over 1 minus 2x. Now, when it is a division, so it becomes a minus. So this becomes 1 over 2 ln, you have a bracket here, 3x plus 1 minus ln 1 minus 2x. Now then we differentiate each of them separately. So dy by dx is equals to half. Differentiate ln is 1 over the function. So this is 3x plus 1. Differentiate the inside. Alright, 3x plus 1 is actually 3. Now, there's a bracket here. So minus. Now, same thing for this. So it will be over 1 minus 2x. Then you differentiate the inside, which is minus 2. Now, you differentiate minus 2 because of this minus, it will become a plus now. Then you have a 2 here. Alright. Now, you can put this as single fraction. If not, you can just leave your answer this way. Now let me put in single fraction, but in exam you can always just leave it, you will already get full marks, okay? So 1 over 2, the denominator will be, so you do a cross multiply, you have 3 minus 6x plus 6x plus 2. Alright, so you have 5 over 2 into 3x plus 1 into 1 minus 2x. Okay, now the 5 you can put over here looks better. Okay, but just leave it this way. Now let's move on to part E. Now, so we can rewrite E as what the expression in part E as 2 into 3 minus x to the power of minus half. Now, so dy by dx, this is simple, you just differentiate. Now the minus half you bring down, so you become minus 1 multiplied by the 2. Then this becomes 3 minus x minus 3 over 2. Now this becomes minus 1 if you differentiate the inside. So you have 3 minus x minus 3 over 2. So you can write it as 1 over square root of 3 minus x. Let us try part F. Now let y be equals to 3x squared cos cube into 2x plus pi over 3. Now, so if we do a dy dx, now how are we going to differentiate this? This is a product of two functions. There's one function here and another function here. So we use the product rule. But within this, all right, this whole thing, how we differentiate this? This one we use a chain rule. All right, so it's a product rule plus a chain rule. Now this is the product rule. Now let's keep this. Let's try to differentiate this. Now so that we bring down the 3, so this will be 3. We differentiate the cos cube first. All right, so what is the remainder of will be cos squared 2x plus pi over 3. Now, then after that, we differentiate the cos. When we differentiate a cos is minus sign. The inside remains unchanged. Then we differentiate the inside, which is a 2. Now we differentiate the 3x squared, so it's a plus. So you got 6x, and this one stays. So cos cube 2x plus pi over 3. Now then we can do a factorization. Now look at these two terms. What is common? 3x is common. So we simply take out 3x. Now if I take out 3x squared, if I take out, I will left with an x, then multiply by this, so I got 3x. Now you look at this term, cos x squared and cos cube. Cos squared and this is a cos cube. What is inside here is the same. So I can take out cos squared. So I have cos squared into 2x plus pi over 3. Alright. Now so this one is this is already taken out. So I'm left with this. So let us just copy down. Now this minus I can bring it out. So I have my sine 2x plus pi over 3. Oh, there's a 2 here. Never mind. I just put it here first. Okay. So here I have taken out a 3x, so I'm left with 2. So I have a plus 2. Now I take out a cos squared, this is cos cubed, so I left with cos 2x plus pi over 3. Alright, then I do a close bracket. Now I can simplify this further, but there's a 2 common, so I can take it out. So what is outside? What then becomes 6x cos squared 2x plus pi over 3 close bracket. Now the 2 is taken out, so I'm left with minus 3x sine 2x plus pi over 3. Alright, this 2 is taken out already, and then followed by plus cos 2x plus pi over 3. Alright, so we have worked out part F, and now let's move on to G to the power of 3. So part G, this is the last question. Now we can use quotient rule for this, which is going to be quite complicated, all right, but it's not that you can't. I think you should try, okay, but the final answer is the same if I use it to do another way. Now you look at this, this is going to be very complicated if you use quotient rule. So what happened is I can make use of log, all right, the properties of log. So perhaps we can just log both sides, all right. We do a ln. So if y is equals to this, then ln y will be equals to ln of 1 minus 2x cubed. Now I ln this whole thing because it's a division, so it's minus ln of square root 4x minus 3. Alright, now this 3 I can bring it down, so I get ln 1 minus 2x minus the half, I can bring it down, ln 4x minus 3. Okay, close bracket. So let's differentiate this. Now this is a composite function. So differentiate of ln y is simply 1 over y. Then you differentiate y with respect to x. So you got dy by dx. And that is equals to, now 3. Now I differentiate ln, I get 1 over 1 minus 2x. Then I differentiate the minus 2x, I get minus 2. Minus half here. Now differentiate ln, I get 1 over 4x minus 3. And then I differentiate the 4x minus 3, I get a 4. Okay, this and this can be simplified, so I left with a 2. Okay, now so I have, now then I cross multiply, so dy by dx will be equals to y. Now let's simplify this. So I have minus 6 over 1 minus 2x minus 2 over 4x minus 3. Okay, so I can do a cross multiply. So I get y into minus 24x plus 18, and then over here I got minus 2 plus 4x over 1 minus 2x into 4x minus 3. So I got y into minus, this becomes 4 x minus 3 to the power of 3 over 2. Okay, so this is a pretty long and complicated sum. Complicated in the sense that it's the algebra of it, the last part of it, all right? Now, to differentiate this is quite simple, all right, if you use ln, all right, but it's the simplifying. Okay, for that, we have come to the end of this video. Thank you very much. Please keep a lookout of more of our videos. Thank you for watching and have a nice day.